Hello everyone, this is the another video in which I will be explaining the GCD greatest common divisor of two numbers. So I have explained this problem in my previous video, but in which I have covered the 7 basic math problems, but I have not explained well enough in that video. So I am creating another video that is this is for explaining the how to find the GCD of two numbers. So firstly, what is GCD? GCD means the greatest common divisor. So if we have to find the GCD of two numbers, let's say for the GCD of whatever numbers, they can be like a comma b. So whatever the divisors are there for a and b, the largest number and the common number among all those sets of divisors of both a and b, that largest number is the GCD, or the it is the highest common factor. So whatever the sets are there for the divisors of a and b, among those whatever the largest and the common number is there, that is the GCD. So now let's get into the example to understand more about this. Firstly, we are having this example that I am having the two numbers, let's say 12 and 18, and I have to find the GCD of these two numbers. So in order to find the GCD of these two numbers, firstly what I can do is the simplest approach which I can follow, that I want I will be having the divisors of 12, all the divisors which are available, and whatever the divisors of 18 are there, I will be taking all those divisors. Now here I can see that which is the largest and the common number, that is 6 in this case. So 6 is going to be the GCD, that is the largest divisor. As I have already talked, that whatever the numbers we are having, we will be taking all the divisors of first number and all the divisors of the second number, and whatever the number is largest and common among both the sets, that is going to be the GCD, because that is the number which is dividing both the numbers, leaving no any remainder. It means leaving the zero remainder. So in this case, the GCD of this 12 comma 18, it will be 6, as it is already mentioned here. Now how can we solve this, or how we can calculate the GCD? So I will be taking that all the divisors of, I will be just keeping an eye on all the divisors of this 12 and all the divisors of this 18, and the moment I will get a common number, or the largest number, common and the largest, that is going to be the divisor. So I will be firstly having the brute force approach, I can say the naive approach which we can think. So here I have again taken the same example, that is 18 and 12. So here I have written the this divisors of 18, 1 2 3 6 9 18, and I have taken the divisors for 12. Now here I can see that again this 6 is the number which is largest and common among both the sets of divisors. So 6 is going to be the GCD. Now again for the second example, we can see that GCD of 48 comma 18. So all the divisors of 48 I have mentioned here, and all the divisors of 18 I have mentioned here. Now we can see again that 6 is the number which is largest and common among both the sets of divisors. So again this is the number, or we can say the largest number, which is dividing this 18 and 48 both. So therefore it is going to be the GCD. So here again 6 is the GCD. Now 40 and 20. So 40 and 20, again 40 is having these divisors, 20 is having these divisors. Now whatever the number of divisors we are having, among those 40 is the 20 is the largest number and the common number, which is dividing both 40 and 20, leaving remainder 0. What is the pattern we have just seen here? That what the two numbers which we are having, that is a and b, just whatever the minimum values we are having, in this case 12 is the minimum, in this case 18 is the minimum, and in this case 40 and this 20 is the minimum. So here what we can see is that whatever the minimum value is coming out of a and b, your divisor will be lesser than or equal to that smaller value among a and b. Because just think that we are having this 18 and 12. Can there be any number which is greater than 12 but it divides both 18 and 12? Can there be will there be any number which is greater than 18, so it divides 48 and 18 both? Will there be any number which is greater than 20, then it can divide both? No, because if any number is greater than this smaller, it cannot divide 12. Which is any number which is greater than 18, it cannot divide this 18. Any number which is greater than 20, it cannot divide 40. So even if this 40 is having the 40 as a divisor, but obviously it cannot be the number because it cannot divide 20. We want the number which divides both the a and b and leaves the remainder 0. So the thing is important point is that divisor, whatever the divisor comes, that divisor will be lesser than or equal to minimum of a comma b. So whatever the values we are given with to find the divisor, to for which we have to find GCD of a comma b, the minimum value among those a and b, this divisor is going to be lesser than or equal to that minimum. So why should we check for all the numbers uh, like from 1 to 18 or from 1 to 48? We already know that the divisor is going to come from 1 to 12 only. The divisor is going to come from 1 to 18 only. The divisor is going to come from the range 1 to 20 only. Why should we go beyond that minimum value? So we will be just checking for all the numbers, and if they and among those whatever the numbers will be dividing both the numbers, we will be taking them, we will be considering as a divisor for this. And till 12 we will get a number which the last number which divides both a and b, that is going to be the GCD, or the greatest common divisor. So what the steps are for this, I have just put a note for this already. When I was learning, I have just kept the note for this. So let's just see here the steps. Firstly, what I am going to do is I will be just maintaining a largest divisor, and as of and in the just at the start I will be keeping 1 as the largest divisor, because uh, as of now I know that 1 can be the maximum number, or the largest number which divides both a and b as of now. And after that, when I will be looping from 1 to minimum of a comma b, I will be just doing this, that checking for every number with 1 for, then for 2, then for 3. So if 1 divides both, I will be just updating this largest divisor by 1. Then I will get to know that yes, 2 is also dividing. Then I will update this by 2. So now if we see this example, this 18 comma 12. Firstly, let's take this example 1. So let me just copy this from here. Let's just run this particular example on this code. So I am just starting from 1 and going to minimum of a comma b. Minimum of a comma b is 12. Now I will be running the loop from 1 to 12. Now at the start, 1 divides both a and b, yes. So I will be updating this largest divisor by 1. So let's keep a variable for the largest divisor. The largest divisor is as of now 1. Now when I move to 2 for the next value, 2 divides both a and b, yes, 18 and 12. So again this will be updated with 2. Now 3 divides both, yes, 3 also divides, so 3 this will be updated with 3. Now 4 divides 12, but it doesn't divide 18. So in that case, I will be not taking 4, because the condition goes false. 5, the again condition goes false. For the 6 is dividing 18 and 12 both. So I will be updating it with 6. Then I will be checking for 7, no. For 8, doesn't divide. 9, no. 10, no. 11, no. 12, no. So now the loop is ended, and the last value in the largest divisor, whatever is the value I have kept, that is the largest divisor. Or I can say whatever the last value is updated inside the largest divisor, that is the value, or as the GCD of a comma b. Okay, so this is all about this approach. So it is that simple. Now one more thing is that so let's just firstly code this. So let's come here, and now what I'm going to do is firstly see, there can be different cases. Either we can have the a and b values which are zeros, means if any of the value is 0, or if there can be also the negative value. So in that case we will be just taking their absolute values. So absolute value of a inside a, and absolute value of b inside b. So I have taken the absolute values. Now there might be the case that if any value among this is 0, so if a is equal to 0, then we will simply return b from here, because a is 0, so another value is going to be the value. So it's like that whatever the GCD you are finding, let's suppose if you are finding the GCD of something, and if any of the number is 0, so in that case the result comes out to be that non-zero number. That's what I am writing here. And if, let's say, in case b is equal to 0, and in that case I will be just returning a in that case. This is we have seen for the edge cases, that if any values are negative we will be converting in them into the positive, and if any of the value is 0 then we will be returning the another value as the GCD. Now what we have to do here is we have to just maintain a variable by the name largest divisor in order to keep the update of the new largest divisor. And here I will be running a loop for this, where I will be running from the loop from 1 to minimum of a comma b. So this is for int I equal to 1, int I equal to 1, I less than equal to minimum of a comma b, minimum of a comma b, and I plus plus every time. And inside this, what I will be doing, I will be updating that if I see that condition that if a modulus of I is equal to 0, and if b modulus of I is equal to 0, it means I've got a number which is dividing both the numbers, leaving the remainder 0. So in that case I will be updating this largest divisor by this value I, and at the end, after completion of this entire loop for loop, the last value which is updated inside the largest divisor, that is going to be the GCD. So here I will just return the largest divisor. This is the entire solution of this. So let's just run this firstly. Let me give the input here. So the input I can just give like 18 and 12. Let's just run for this. So for 18 and 12, it will be giving the output as 6. This okay. So the GCD of 18 and 12 is 6. Let's check for the another output. Another input. Let's say I'm giving 15 and 25 here. So in that case, what the output will be coming? It should be like 5. So the GCD of 15 and 25 will be coming as 5. Yes, it has given the output. Now one more thing is there. See, we are checking for the largest divisor, obviously. So we know that whenever the largest divisor will be coming, and we are going from the loop 1 to minimum of a comma b, we know that the largest divisor is going to come which is lesser than or equal to minimum of a comma b. That thing we know. But one more thing is there, the fact that the value which is going to come, that will be closer to minimum of a comma b, because that is the largest value which is going to divide the both the numbers. If that value is close to minimum of a comma b, then I can run that loop from starting from minimum of a comma b and go till 1, so that I can get my result in a lesser number of iterations. So in this case, what I can do is I can just loop starting from minimum of a comma b and go till 1. This is how. And in this case, whatever the first value which I will be getting, because what I'm saying in this case, what happened is that I'm starting from 1 and going till minimum of a comma b, and the last value which got updated in the largest divisor, that is going to be the result. And this, or just opposite, is happening here, that if I am starting from minimum of a comma b, then here last value which got updated, and that last value which got updated, that last value is going to come first in this case. So whatever the first value I will be getting here while iterating from minimum of a comma b till 1, the first value which I will get, that is going to be the GCD, and that is going to be the largest divisor which divides both a and b, leaving the remainder 0. So in that case, the first value which I will get, which is dividing both a and b, that I am going to return directly, because that is the GCD. So I can just make this particular code. Let's just comment this here, and let me write in this way that I am not having the need of this. Okay, here I will be running this loop starting from minimum of a comma b, minimum of a comma b, and here I will be running this loop for greater than equal to 1. Okay, and here I will be decrementing this I again and again, and whenever I will get this value and any value, the first value which is dividing both a and b, I will be just returning that I here. Okay, because that is the uh, value which is going to be the GCD, that is the largest divisor. Okay, and in this, as I have already returned here, now what will be the case because this function is having the return type of integer, we will have to return something. So let's just return 1 in this case, because see this particular line, if we see here, edge cases are already covered, that if any value is 0, then next another value is going to be the GCD. If a is 0, then b. If b is 0, then a is going to be returned. Also we have put the cases for the negative values. If the numbers are negative, then in that case we will just take the absolute values of those. And from minimum of a comma b, if any of the case happens, like if we are finding the GCD where both the numbers are having 1 as the uh, the divisor, so in that case it will be going till 1 and it will just return 1 here. So this line is not going to be executed anymore, so we just have to place it so that the compiler do not give any undefined behavior. Okay, so now for this example as well, if we run this particular code, let me give the another input, let's say 48 comma 18, and let me run this code. So it should give the output where the GCD of 48 and 18 will be 6. Yes, so yes, the GCD of 48 and 18 is 6. Okay, this also works fine. Now the important thing is that we are finding the GCD here, and in with the help of this approach, but we can see that this loop is running for 1 to minimum of a comma b. So we can see that the time complexity which goes in worst case, that will be big O of minimum of a comma b, which I have also already mentioned here. And same thing in this here, even we are doing this thing that we are starting the loop from minimum of a comma b and going till 1, so that it covers in the minimum number of iterations. But what if the case that if I have to find the GCD of the two numbers where both of those numbers are divisible by, they are having the divisor as 1. So if I have taken this example GCD of 13 comma 17, now both of the numbers, if I take the minimum of this, that will be 13, and therefore this loop will be running starting from 13 till 1, because 1 is the divisor, the greatest divisor, which will be giving the which will be dividing both these numbers. So in that case, this loop is going to run from minimum of a comma b till 1 whole. So it means again the time complexity goes to big O of minimum of a comma b. Okay, so again in this case, the time complexity, if we see for the worst case scenario in both the cases, that is going to be minimum of this minimum of a comma b, big O of minimum of a comma b. So we need to reduce the time complexity. So in order to do that, we will be going into the another approach, that is the most famous one, that is Euclid's algorithm. So what the Euclid's algorithm says is that that whenever we have to find the GCD of two numbers, let's say a and b, so now the Euclid's algorithm says that according to the Euclid's rule, that if we have to find the GCD of a comma b, then it will be equal to GCD of a minus b comma b, and then these subtractions are done till both the numbers are becoming same. And the point where both the numbers become same, like what, like GCD of a comma a, so in that case you will be just returning a, because both the numbers are same, and in that case you will just return that a value. So that is going to be the GCD. This is the Euclid's rule. If GCD of a comma b you have to find, so GCD it is equal to GCD of a minus b comma b. Now one catch is here, that whenever we are doing the subtractions, in that case the GCD of this particular these numbers do not changes. If we are finding the GCD of a comma b, and if we are performing the subtractions like a minus b comma b again and again, the GCD of these numbers are, sorry, the divisors which are there for the common divisors, they remains the same. How? Let me explain that. Here I have already kept the reason. Let me firstly explain that how this works. So let's suppose that I have to find the GCD of that same example I am taking, GCD of 18 comma 12. Now we can see here that what are the divisors for 18. The divisors for 18 are like 1 2 3 6 9 and 18. So these are the divisors for 18. Now if we see the divisors for this 12, the divisors are 1 2 3 4 6 12. These are the divisors for 12. Now here we can see that these are the common divisors, 1 2 3 1 2 3 1 2 3 is there, 6 and 6 is there. So 1 2 3 6 and 1 2 3 6, these are the common divisors for 18 and 12. Now let's perform the subtraction in this. So if we perform the subtraction, how the subtraction is performed, the greater minus the smaller, where it is given that a is greater than b. So when we perform this a minus b, here a is greater, that is 18, minus the smaller, that is 12, and whatever the smaller number is there, it remains as intact, that is 12 here. So now what it gives? It gives the GCD of, the difference is 6 here and comma 12. Now here let's again see that this divisors of this 6 and 12. So if we see that for the divisors of 6, they are going to be like 1, 2, 3, and 6. Okay. And for 12, if we see, so the divisors are like 1, 2, 3, 4, and then 6, and then 12. So these are the divisors for 12. Now see the common divisors: 1, 2, 3, 6, 1, 2, 3, 6. You can see here that if you are performing the subtraction, and this, whatever the repeated subtractions you are performing, after these repeated subtractions, the common divisors do not are not affected, or they are not changed. So even if we are performing the subtractions, those divisors do not change. That's the reason I have mentioned here that any, and the one more important reason is that any of the number, let's suppose d is the number which is dividing a and b both, so that will also divide a minus b. If any number is there which is dividing a and b, then obviously it is logical that it should also divide a minus b. So that's the case. If a and b are divisible by any number, then that number should also divide a minus b and also b, and therefore it will divide a, whatever the number is there. That's just a kind of circular logic. So the reason is that any number that divides both a and b must also divide a minus b, that I have just written here, and any number that divides a minus b and b must also divide a, which I have just explained. So the set of common divisors stays exactly the same, like in this case 1, 2, 3, 6, 1, 2, 3, 6 are common. Here again 1, 2, 3, 6, 1, 2, 3, 6 are common. And further, if you also make more such iterations, you will get that the common divisors are not affected, they are staying the same. So you can perform this subtraction until both a and b are becoming same. Here again one more example, I have taken this GCD of 48, 18. So if we are performing these subtractions like greater minus smaller, so 48 minus 18, it becomes 30. Again 18 is subtracted, so this 30 is greater and the 18 is smaller, so 30 minus 18, 12. And further these subtractions are made, and the moment these both the values a and b are becoming equal, one of the value, that is a, is returned. Now both a and b are same, so 6 will be returned, therefore the GCD of 48, 18 will be the 6. Now the thing is that, see, we are performing these subtractions again and again until we are getting a particular values where a and b both are becoming equal. Now it is good for the smaller inputs if the values are smaller, but if the values goes larger, it means whatever the a and b values are given to whatever we have to find the GCD, if the difference between both of these values is just smaller, and just take the worst case that if they are the, we have to find the GCD, so in that case the difference between both the values is 1, then in that case we can just see here that first operation which we perform, the subtraction, it will give 1, and now you will have to subtract this 1 as many number of times. How many number of times? You can just see from here that uh, firstly you have taken the difference, it gives you 1. Now you will take this greater and this is smaller, 1 is subtracted, it gives the 98. Again 1 is subtracted, it gives 997. So in order to reach a point, how many times this number has to be subtracted? Like in order to make this particular number, where the, in order to reach a particular point where both the numbers are getting uh, it is the point where the how many number of times you will have to subtract this one, that is close to 1000 times. You can see from here 997, after again minus 1 is done, again minus 1 is done, so it is close to, you have to do it maximum of the value, whatever the maximum value is, that is in this case 1000 times. You can see here the time complexity of this is going to be big O of maximum of a comma b. So that is again a kind of a brute force only, we can say, in the Euclid's algorithm. And let's just go into the code part, and let's see for this how we can write the code. So what we have just done is, what we are doing, we, whatever a comma b we have to find the GCD, we will be just it will be just equal to the GCD of a minus b comma b. So whatever the greater number is, it is going to be in this way. If whatever the greater number is, let's say a is greater, let's say a is greater than b, then in that case the difference you will be calculating, that is going inside the greater, in place of the greater value. So a equal to a minus b, and in case if b is greater than a, then in that case that will be going inside the b, that is b minus a. So that's the whole point. Let's just go into the code part. So this is for the Euclid's algorithm, and firstly let's take the similar thing, that a is equal to absolute value of a, okay, and inside b we are taking the absolute value of b, just for the negative, just for the cases of negative values. and if any of the number like a is equal to 0, then you will be just returning b, and if b is equal to 0, then in that case you will just return a. Now here, if this a and c, what is happening until the means till the moment this a and b are not become equal, till then you have, till that point you have to run the loop. So till a is not equal to b, just run this loop, and what you are doing inside this, if this a is greater than b, then in that case you will update this, whatever the, see, a is greater than b, so you will find the difference, that is a minus b, so it will be going inside or we can say at the place of a, so that is a minus b, and else obviously b is going to be greater, so in that case we'll just put this b minus a inside b. That's the whole point. And the moment this a and b gets equal, if this a is this is the example 48 and 18, firstly you will perform some subtractions. 18 will be subtracted, then 18 will be subtracted again, then 12 will be subtracted from this 18, then 6 will be subtracted. The moment both the values becomes equal, you will just return from there and return a. Any of the value you can return because both are the same, so you are going to return a. Now just let's take the similar for the run for the similar example. Here run this code, so it is going to give the same result. Let me just run this code for the another input. Let's say 40, let's say 1999. The GCD of 1999 will be, okay, so the GCD is going to be 1, obviously, because the number of times this you have firstly performed the subtraction, so it gave you this number 1. Now 1, and this is this number, again subtraction, again subtraction, again subtraction, and it will take at the moment where both the values are becoming same, so in that case it will give the 1 in this case. So in that case this particular approach is not good because it is going till maximum of the value among a and b. So that's why this approach is not that better. So here we have seen the code part for this, and yes, whatever is the maximum value of a and b, that is going to be run. So the time complexity for this big O of maximum of a comma b. Now we will have to get to the better approach. Now Euclid's algorithm is just a modified of this. See, what we are doing is, let's come here. What we are doing, we have taken this 48 and 18, we are performing the subtractions. We have performed this the greater minus smaller, so it gave 30, then again this greater minus smaller, so it gave 12, again this greater minus smaller, so it gave 6, then again this. So what we are doing, actually we are just doing the multiple subtractions. So instead of why, so instead of this doing the multiple subtractions, why can't we divide this number once with this number so that it gives the remainder at once? Because we firstly subtracted this 18, then it gave this, then we subtracted 18 from this, then it gave 12. We have to perform the 18, we have to perform the repeated subtraction for 18 two times, and then it gave this 12 as a value. So why can't we just divide this 48 by 18, and at once only it gives a remainder, which is the result. So this remainder is nothing but the repeated subtraction here. So we can just map in this way, that this remainder is nothing but the repeated subtraction of these values. Instead of performing the repeated subtractions, we can just divide that value once, so that we can then get the result as the remainder at one step itself. So that's how you can see here that this is the smaller example. If I take the bigger example, then in that case the number of steps which are taken in this, they are decreasing like drastically when we are performing this kind of this Euclid's algorithm. So it is just having the highest performance as comparison to the subtraction part, subtraction method. So therefore, the way we are writing this rule, that this GCD of what we are writing in that previous approach, that GCD of a comma b is equal to the GCD of a minus b comma b. That's what we are writing, that we are performing the subtraction again and again. We are subtracting this b again from this, again from this, repeated subtractions. We can just divide this a by b, and whatever the remainder comes, that you take instantly. See, you can see in this example, either this is the smaller example, but yes, it is understandable. So this is the example I am solving for this GCD of 48 comma 18, and after that I am performing this subtraction, so it becomes 30 comma 18, obviously this, and after that again subtraction goes, so it goes to the GCD of 18, 12. What I am doing here, I am just it I have performed two times subtraction by 18, and after that I am going to this step. I can simply divide this 48 by this 18, and I will get the direct result, that is as 12 as a remainder, which I am getting after two subtractions of 18. I'm going just inside in the one step. So you can see, if I take any bigger example, it is going to more understandable, obviously. So from this we can understand that instead of doing the subtractions, we can just perform the modulus operation in this case, and we can just get the remainder directly, this 12 as a result directly, and whatever the number is there is smaller, that is going to come intact. Okay, so whatever the greater and the greater number, whatever is the greater number, greater modulus smaller, we are going to perform this. Whatever the greater number is there and the modulus with the smaller, that is going to that is just going giving me the remainder. And then whatever the remainder comes, this is actually the remainder. Okay, now whatever is the remainder coming, it is logical that whatever the remainder is going to come, that is going to be smaller, even smaller, exactly strictly smaller than this smaller value. So if we are performing this 48 comma, you can just see from here, we are performing this. If this is a is a number, that is 48 we have taken, and we are multiplying this 18 with something and getting some remainder, this remainder is going to be this a modulus of b. And this is a simple math, that if I am performing the modulus of a modulus of b, the remainder whatever I will be getting, that is coming in the range 0 to b, lesser than b, where 0 is included, b is not included. So whatever the remainder comes, it comes from 0 and lesser, strictly lesser than b. Okay, so this b is going, then b is becoming the greater, so it will be going at the place of a, and then remainder is going to be strictly lesser than b, so it will be coming at the smaller value, that is at the place of b. That's how we are swapping the values. So that's the simple approach which we can follow, that instead of doing the repeated subtractions, we can just perform a single modulo operation, which can just reduce the steps drastically. Okay, and also the time complexity, which we'll see in a while, meanwhile. So this is the case we are this is the case happening. So for this we are just writing this rule, that GCD of a comma b equal to GCD of a modulus b comma b. So whatever the remainder comes, it becomes even lesser than b, so b will be going at the place of a, or you can just also write this in the way, in this form, that GCD of b comma a modulus of b, because b is going at the place of a as the greater number, and a modulus of b, which is the remainder, which is exactly lesser than b, so it will be going at the place of b. That's what this Euclid's algorithm, optimized Euclid's algorithm, says. Okay, so now let's just get into the code part firstly. So here again, uh, I am having these values, so I will be taking the absolute values of this, absolute value of a, and for b again I will be taking the absolute value of b, and this is for the negative values. And if any a is equal to, okay, so if any a is equal to 0, then in that case I will be just returning b, and if this b is equal to 0, in that case I will just return a. Now here the point comes. Now what's the point here? Till what moment this loop will run? See, here what is happening in the subtraction, when the a and b becomes equal, and even after that if you perform the subtraction, so the smaller value will be whatever because both the numbers are equal, so you can take any of the number and comma 0. So if in that case we are saying that if both a and b becomes equal, so any of the number will be returned, that is as a GCD. And same thing happens here in this case, that after performing this modulo operation, at the end when the remainder comes as 0, the remainder obviously that is coming at the place of b, so we can say that the moment b becomes equal to 0, we will have to just stop, and the last divisor which we got, that is going to be the result. Okay, every time the remainder is coming at the place of b, so b is just decrementing ahead again and again and again, decrementing and going till 0. Okay, and this b is going at the place of a, obviously. So we are just checking for the b, that the moment b becomes 0, the remainder becomes 0, so the last divisor which we got, that is going to be the result. Simple. So b, the moment b is equal to 0, we will just run this stop this loop, and inside this what we have to do, that we have to calculate the remainder, int remainder equal to a modulus of b. And now, because this remainder has to go in place of b, firstly b will have to go in place of a, so that is a equal to b. We are just swapping these values, and then this remainder will come in place of b. And this is how, when this b becomes equal to 0, at the end we will just return a. That is the entire code for us. Again, let's run for 48,18 again. For this, the result 48,18. Let me just this code. There we, and the output of this 48 and 18 going to be 6. That's great. And let's say if I'm taking another example, let's say 13, let's say 13 comma 17 going to be 1. So yes, the output is 1 in this case. That's how it is running. Now let's check the time complexity. That is the most important part in this. See, the time complexity, how I can explain is, see, if I am having these values, if I was checking for these values 48 and 18, and this, it is just a simple just to explain. For the time complexity, how it is happening, let's just take this example, this 10,000 9,999. Here if you perform the subtractions, if you perform the subtraction method in this, then how many number of subtractions you will have to make? That's just similar to this example, that you will have to make 1,000 10,000 subtractions close to, that is the maximum value of a comma b. And if you perform, that is going to the time complexity takes to maximum of big O of maximum of a comma b. But if you perform this method optimized, which is the this modulus operation method, now in this case you can see that if you are performing this modulus operation, in that case you are getting this 1 as a remainder here, and again when you perform the modulus operation you are getting this 1 comma 0. You can just see that the 10,000 steps which are required, then 10,000 iterations which are required in this subtraction method, those are just boiled down to the 2 steps itself. In the 2 itself, you are in the 2 to 3 steps, you are just getting the result. You can see that how the number of iterations are dropping drastically from that subtraction method to the modulus operation method. So it's that simple. From this input you just got to this after performing the modulus operation, and after performing one more modulus operation you get to this particular step. So the algorithm, this Euclid's algorithm, it is having the number of steps which are in the logarithmic way. So even if here we have taken one example. Now if I take the most worst case scenario, and the worst case scenario can be what? The worst case scenario can be that if you are given with the numbers, let's say you are given with some of the numbers, let's say 5,8. Now here you can see that 5,8 are the numbers which are the consecutive Fibonacci numbers. How the Fibonacci series is going, goes like 1, then 2, then 3, then 5, then 8. So out of this Fibonacci series, out of this Fibonacci numbers, if any of the two consecutive numbers are there, like this 5,8, or if any of the number, so in that case how this algorithm works, firstly it takes the difference, so it will take the difference 3, and then 3,5 will become, so now this number is becoming 3, this it takes to 3,5, and when 3,5 becomes, it takes to, the difference goes to 2, and 2,3, so 2,3 comes, then the difference comes 1, so 1,2, so 1,2 comes, and that's how if you are taking in this way, that Fibonacci, that if you are having such numbers inside the GCD, you are having such numbers inside the GCD where you are having numbers like f of n, comma f of n minus 1, comma f of n minus 1. So in this way, if you are having the numbers in the you have to find if you are finding the GCD, and if you are having two numbers which are consecutive from the Fibonacci series, that is going to be the worst case, because in that case, whenever you are performing the modulus operation and getting the remainder, that is taking you to the previous, just the previous one. So after this, if you see, after this step, let me just write here. After this step, if you see, so when you perform the modulus operation among these, the greater and the smaller, you will get a number like, you will get the two numbers like f of n minus 1, comma f of n minus 2. Okay. This is how you will be getting. And after that, again, when you perform the operation, it is just going to be decreasing on the basis of the consecutive numbers of the Fibonacci series. So that is going to be the worst case. And in this worst case scenario, you can just see here that we already know that the Fibonacci series grows exponentially. Okay, Fibonacci series grows exponentially, and because of which the number of steps are number of steps required are logarithmic iterations. Okay, or logarithmic iterations or logarithmic steps. So because this Fibonacci series grows exponentially like 1, 2, 3, 5, 8, and when we are performing this GCD on two numbers which are the consecutive from the Fibonacci series, they are going to decrease. Obviously they are going to decrease, so they are going to decrease just logarithmically, because it is just going to be, we can say, just opposite, we can say, in that way, because this Fibonacci series is going from like exponentially growing 1, 2, 3, 5, 8 and more. But whenever we are taking the two consecutive numbers from the Fibonacci series and we perform the GCD, we have to find the GCD. So in that, whenever the modulus operation is performed, the numbers decreases, and numbers will decrease because this series grows exponentially. So when it is coming down, it is even, the number of steps required are very small, or we can say the logarithmic iterations or the logarithmic numbers, because whenever the division happens, we have already seen in the, like, in the problems which I have solved in the previous video, that is 7 basic problems. Out of this, if we see the problems where that whenever the division happens, the number of steps or the number of iterations required are logarithmic. So that's how same happening here. Whenever the division happens, we can also think in that way. There are the different ways to think, like how, why the time complexity is logarithmic. So the one simple is using the worst case scenario like Fibonacci series, or I have given this example where again it is changing drastically, so that is dividing. Or you can also think of that we are performing this modulus operation, so because of performing the modulus operation, every time it will be divided by some another number, by some different number. So in that case, you can just think of the log of phi like that. Okay, so that's what it is all about. The time complexity of this is going to be log, and I should say minimum of log of minimum of a comma b. Why minimum? That's quite simple, because if we see in the example like this, I have solved 48 and 18 we have taken. So here we can see that this b value 18, how it is changing. Firstly, b value was this, and we can see b value was 18. Okay, this was the value, and after that it decreases again it decreases, again it decreases, because the b value is decreasing. How? Let me just explain that as well. Let's say we are finding the GCD of, just that we are finding the GCD of any two numbers, and let's say 100 comma 37, let's say. So now the b value is this. Okay, after this, whatever the remainder will come, that remainder is going to come lesser than, strictly lesser than 37, because when you perform 100 modulus 37, it will give a remainder, and that remainder will be from the range 0 till less than, strictly lesser than 37. And again, when this, and that remainder when will be coming at the place of b, obviously, because b, then b is going to be greater and it will go at a place. and that remainder will come at b place. Again you will find the remainder, again that remainder will come lesser than the previous remainder. Again you find the remainder, again that remainder is going to be lesser than the previous number. Okay, and every time, because this remainder is lesser, okay, so b is decrementing in logarithmic steps. B is decrementing in the logarithmic steps. So b is somewhat any number, any non-zero number, then it decrements, and again it decrements. So remainder is like, it's like this, that if we are finding the GCD of a comma b, then when you perform this a modulus b, okay, so in that case what happens is this remainder is greater than, the remainder is greater than equal to 0 or lesser than b. Okay, so that's what the case, like b is any non-zero number, then it decremented to some remainder, then again what some remainder came, again it decremented, again it decremented. So sometimes this remainder decrements to even the half of b, and like remainder is always obviously lesser than b, so sometimes this remainder gets half of b, and also even like remainder sometimes gets lesser than b and even gets lesser than the half of b. So that's how it goes from a non-zero number to half of the number, then half of the number, then it goes to 0. So that's how the time complexity of this code, of this approach, it becomes log of minimum of a comma b. Yes, that's why we are taking minimum of a comma b. Whatever the minimum value will be there, those steps will be depending on that minimum value, that how that minimum value is decrementing logarithmically. So that's how the time complexity goes to that minimum value of b. It depends on the minimum value, like this 37, how it is decrementing. 37, then some value will come, like whatever the remainder will come, that will come in place of this, then that, then another value, then another value, and then it reaches to 0. So that's how at what number of steps, at what number of iterations this minimum value is going to 0, that's what matters. So we are taking, that's why we are taking the minimum of a comma b, and then we are taking the logarithm, because it is dividing every time with some number, again it is dividing with every time with some number. Okay, so every time the division is performed, and because of which the numbers are getting reduced to 0. Okay, and that's why it is becoming logarithmic iterations or logarithmic steps. So that's what the time complexity. We have just seen this problem.